Because unlike transformations, transformation graphs, usually you had like 2 or 3 transformations you had to do in our first chapter when I got you to graph stuff. For sine and cosine, the exam likes seeing if you can do all 4 at once. And if you did those with the arrows with all 5 points, there'd be a lot of mental math to do, and it could be quite time consuming and easy to make mental math mistakes. So we have a shortcut for graphing both of these. And I call the shortcut DABC. Because the shortcut, you know how normally you would do your stretches and compressions first. This is still transformations. You have to do stretches and compressions first, then translations last. However, since your sinusoidal axis is at 0 to start with, multiplying it by anything doesn't change it. The only thing that changes it is if you move it up and down. So we're going to be able to do a shortcut and start with that D value. Then use your A value, your amplitude, to find your max and min. Use your B value to find your period and mark it and divide it into 4 equal sections. The dash is part of the strategy. It's not just because DAB doesn't sound as good, DABC sounds better. It's not because of that. The dash will actually draw the graph with the dotted line before the shift and then add the shift after on the same graph. So just like we did each thing separately in the last chapter where we did the amplitude, saw what it did. Did the D value, saw what it did. Did the B value, changed the period. We can now combine those all 4 together easily. So let's just review. If you started with your D value, what do you do with your D value? It'll be y equals whatever that D value is, right? Take out a red pen, you would do that as a dotted line, y equals D. So the D value, super easy to do. Then, what are you going to do after the D value? You go to your A value. This is your amplitude. You're going to use your amplitude to label the maximum and minimum. Because your amplitude always starts from your center line and goes up and goes down. So if your center line is at 2 and your amplitude was 3, 2 up 3 would give you a maximum of 5. And 2 minus 3 would give you a minimum of -1. And so we need to find where our maximum and minimum values are. B. Find your period. Your period for sine and cosine is 2 pi over b. Remember, for tangent, it's a different formula. Your period is 2 pi over b. Choose any place on your x-axis. And label your period on your x-axis and divide it into 4 equal sections. The dash. draw your graph without the phase shift, without the horizontal translation, with a dotted line. So that dash is supposed to be like a dotted line part of it. Draw your graph without the phase shift. And your C value is your phase shift. So add your translation or your phase shift. And graph. So this is where if you have a positive sine graph, it starts in the middle going up. If you had a negative sine graph, where does it start? It starts in the middle going down. Positive cos graph starts at a max, and a negative cos graph, that reflection will make it start at a min. So I put all of these ideas all together, creating us a shortcut to graph things quickly with DABC. So we can go, maybe before we do example 1, do you have space at the bottom of this page to graph? We're on page 531, or you wrote this wherever is fine. You have space at the bottom of 531. Let's do one example at the bottom. Okay, let's do an easy example. Graph y equals 2 sine of, let's go 3x plus pi over 12 minus 1. And what I'm going to do up the top here is I'm going to write out DABC. And as I do each step, I'm going to put a check mark to show you what it looks like to do the D value, broken down nice and short and simple. Okay? So, we're going to draw our axis. When drawing our axis, we're going to do a little bit of thinking ahead of time. In this case, I know that my D value is minus 1. So I go on my graph, I write minus 1. I draw a red dotted line. This is my middle line. This is my center line, my sinusoidal axis. Y equals negative 1. That's all you have to do for your D value. Just draw your center line. Once that center line is drawn, we now go on to A. Our A is our amplitude. Our amplitude is 2. Your amplitude will help you find your maximum and your minimum. If my amplitude is 2 and I go up 2 units from my center line, I would get to 1. If I go down 2 units from my center line, I would get to minus 3. All you have to do with your A value is label your maximum and your minimum. Done. So I took my amplitude of 2. That means from my center line, amplitude measures the distance from the center line to a max and center line to a minimum. That is 2 units, so I can label my max and label my min. Your B value finds your period. So if my B value is 3, my formula says that your period is always 2 pi divided by your B value. My period would be 2 pi over 3. I take my period and I choose somewhere along my x-axis and mark it and label 2 pi over 3. Then I take that section and divide it into 4 equal sections. So half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6. And this would make this 1, 2, 3 pi over 6, which you could write as pi over 2. or you could leave it as 3 pi over 6. So the b value out of the first three is probably the most work. You have to find out what your period is, draw your period somewhere on your x-axis, and divide it into 4 equal sections. Then your b value is done. Next, the dash. We draw our graph without the shift. So I'm going to take this and draw it in green. What kind of graph do I have? I have a sine graph that's positive. A sine graph starts in the middle, going up. Okay? Careful, when you go to the next ticky mark, you're going to be tempted by the x-axis. I'm going to tell you the x-axis is super tempting to put dots on it, but we go middle, then maximum, then middle. So don't go back to your x-axis. The middle is, that's why we draw the red line. And then minimum, and then middle again. And I'll draw this with a dotted line. This would be the graph if there was no phase shift. But we have a phase shift here. Each of these ticking marks is pi over 6. So if I made the same ticking mark on this side, I would get to negative pi over 6. I need to do a shift of pi over 12. You see that that's plus pi over 12 would be pi over 12 to the left. Where is pi over 12 on my x-axis? Pi over 12 is half of pi over 6. So if I moved halfway to the right, that would be negative pi over 12. And I would have to cut each of these in half, because each of these points is going to get shifted that half amount to the left. So the dotted line is really helpful because it can show you where the points were, and then the shift is really easy. You figure out how much you're going to need to shift, make those marks, and now we can draw our final graph through those points, put arrowheads to say that it keeps on going, and we've graphed at least one period. So in example 1, we get to do 2 more examples just like this. I'll give you a second to finish writing this down. Once you get really good at DAB C, these graphs are easy to make, and they are always worth 4 marks on the final exam. So a lot of marks. Okay, example 1. Since we've done the DAB C already, this predict, all they would like you to do is, probably on the exam they wouldn't say predict, they would probably say describe. So you could, in each of these, I'm going to change this word to describe. Describe how the graph is related. So, or it would say describe the transformations. So I'm going to color code this. Okay, that 1/4. You could describe this with transformations. This would be a vertical compression. The y values would get multiplied by 1/4. You could describe it as the shortcut that the amplitude is 1/4. Next, the 3. You could describe this with transformations. This is a horizontal compression. Your x values would get multiplied by 1/3. And in particular, that changes our period. Our period is 2 pi over 3. in purple, the pi over 6. That would be a horizontal translation. Pi over 6, x's are lies, so the plus would actually go to the left. And you would say basically the same thing. Sometimes they talk about phase shift of pi over 6 to the left. So that translation part, the c value, you can just describe it in translations would be fine. It changes your starting point, right? So your starting point for a coast graph would be at a maximum. Now that maximum is getting moved pi over 6 to the left. And finally, the 2, in transformations, we would say that's a vertical translations, 2 units up. And this tells us that we have a sinusoidal axis at y equals 2. Describe the graph. We've done that already. We are going to now sketch the graph. They have this. I'm going to change it to at least 1 period, because this in particular would be really, really annoying. And we're going to use DAB-C to graph. So once again, I'm going to extend my page here. I'm going to write off to the side DAB-C, and as I do each of those things, I am going to draw. Yes?
For on an actual, like the exam or a test, would we write it like that, or would we do a paragraph like we did for the...
You would do a paragraph. And if it was a described thing, you'd write full sentences. Really like that. I know. Okay. Now, when drawing your axes, you can use your D and your A, like the D and the A value you actually have to think about early. Because if I just draw this, which is what you normally draw, right? Do you see that your center line is 2? You don't need any negative part. My center line is 2 and my amplitude's 1/4. I don't really need any negative part. So I'm going to take away my axes. I'm going to think about that a little bit early, and I'm actually going to draw it way down there. I know my center line is at 2. And draw that center line at y equals 2. That's all I need to do for my D value. But I already was thinking about my D value and my A value. Because if your A is 1/4, do you see that your maximum would be at 2.25? And your minimum at 1.75. So your scale is important. And when thinking about your scale, you're going to have to sort of take into consideration your D and your A value before you even draw it. So I know that I'm checking them off one at a time, but I thought about both of those to start with. Because I was like, okay, where is it going to be? Where's my maximums and minimums? How much do I need to draw? How can that be helpful? Next, my B value. I know that my period is going to be 2 pi divided by my B value, which is 2 pi over 3. I go along my x-axis, somewhere I mark 2 pi over 3, and I divide it into 4 equal sections. Labeling the middle one is the easiest. Half of 2 pi over 3 would be 1 pi over 3, or 2 pi over 6. Half of pi over 3 would be pi over 6. And then the third one, 1 pi over 6, 2 pi over 6, 3 pi over 6. Again, you could reduce this to pi over 2, but you don't have to. So that is what you do with your B value. Now we're going to draw our graph dotted without a shift. What kind of graph is it? It's a coast graph. It's a positive coast graph. Where does a positive coast graph start? At a maximum. So I draw a maximum. First ticking mark, center line. Second ticking mark, minimum. Third ticking mark, center line. Fourth ticking mark, maximum again. And then finally, so that's the dash check mark there. Finally, we do our phase shift. So we need to go pi over 6 to the left. So I need to label. I've already got pi over 6 on here, so I know that that exact same distance, which is 1 ticking mark in size, I'm going to go 1 ticking mark in size to the left. Now I can take all 5 of those points and shift them 1 ticking mark over to the left. And at least one period of your graph would look like this. If you actually did what the question said, this is 2 pi over 3. That same distance would be 4 pi over 3. That same distance would be 6 pi over 3. You'd have to go all the way up to here if you graphed up to 2 pi. And you would have to go all the way back, way over here, and have lots of squigglies over and over again. And it keeps doing this pattern, right? It keeps doing maximum, then center line, then minimum, then center line, then maximum, then center line, then minimum, then center line. But you'd have to draw all the ticking marks along the way and keep on going until you got to 2 pi. And same thing, you'd have to do the whole thing backwards until you got to negative 2 pi. Okay. So I'd like you to circle 8, 9, 10, and 11. And 11, I put a star beside because I think it is not in factored form. The DAB-C, just like regular transformations, you have to have the middle part in factored form.